Okie dokie. So, you put that on pause and now you're watching the second video. You have already graphed these to the best of your ability. Let's take a look. So if you haven't, you're really not doing what you should be doing for your own learning. Okay, I promise you that if you give it some thought and try, you will learn much more. That said, here we go. So we're going to see if we can kind of shortcut. Okay, we know that there's a number in front of x, and we're trying to figure out what the graph of y equals sine of 4x is. So the period, meaning the time it takes, or the angle that it takes for one complete pattern, is 2 pi over 4, which is pi over 2. So normally we would say 0, pi over 2, pi. But what this is telling us is that this, from 0 to pi over 2, the sine graph is going to make one complete oscillation. So it would go up and down and up. And if you want to do that, that's fine. So we could do this. Oh, hey. We could zoom in and know that it's going to go up to, actually I'll keep this with the color black. Okay, and we could go whoop, whoop, whoop. See how I divided that up into 4 equal sections? And if we were graphing, we know that sine starts at 0, so it would be up, middle, down, middle. One complete cycle, all within pi over 2. So how you actually graph it depends on what values you have on the x-axis, and the values you put on the x-axis should depend on what the period of oscillation is. So if we were to continue that pattern, it would go up and like this, up and like this, up and like this, and so on and so on. So that's one way to do it. If you wanted to make it look a little neater, right, you could say 1, 2, 3, 4, because we know it goes through these sort of 4 patterns, right? Up, middle, down, middle. And we know that the period is pi over 2, so if we split that up, so this is basically drawing this, but just kind of on a stretched out axis. And so you're thinking, well, if that's pi over 2, what's this and what's this and what's this? Half of pi over 2, pi over 4. Half of pi over 4, pi over 8. Whoa, pi over 8. So this would be 2 pi over 8, 3 pi over 8, 4 pi over 8, which simplifies to pi over 2. So this right here, and I know fractions are our best friend, of course, but this is something that we will be practicing with, all right? So there we go. Oh, wait, well, let's actually draw the graph. So it'd be like up, middle, down, middle, where the amplitude is 1, -1. Okay, so either of those, I know that's a little messy, but whatever. Okay, so that we just saw, let's write this out. This is a horizontal, you fill in the blank, that's right, compression. So it's like an accordion. We pushed the normal graph and squished it in. So when the number is less than 1, when k is less than 1, we think it's going to be a horizontal stretch, and by a factor of 4. So if we were to just use our normal pi over 2, pi, 3 pi over 2, and 2 pi, it's only going to show a little bit of the graph. So what are we doing? This is what we're doing. 2 pi over k, dividing by a fraction, same as multiplying by the reciprocal. So what we're getting here is that the period for this graph is going to be 8 pi. What? Yep. So let's be good about this and give it some thought, and then have this affect what values we put on the x-axis. So we know that it starts from 0, and then we're going to count out 1, 2, 3, 4, because I know it kind of goes through four sections of the graph, and we're going to say that's 8 pi. Excuse me. So if that's 8 pi, you can break it down and think about what these would be, right? Half of 8 pi, 4 pi, half of 4 pi, 2 pi. So 2 pi, 4 pi, 6 pi. This one's actually a little easier. 10 pi, 12 pi. Hey, no fractions. We love it. So 1, -1, and our points. So again, if this that I'm writing is like Chinese or Swahili or something like that to you, you should probably set up a table of values. Take these, put them here, plug the values into the equation, and actually give it some thought. So you should be able to do that at this point. If you're being lazy and just letting me do all the work, shame on you. So 0, 0, 2 pi, wait, ooh, this is cosine. My bad. Cosine. Right, and then let's see, 2 pi, so pi over 2, yeah, this is good. And it'd be like this, and once you get here, you know the pattern, right? Up, middle, down, middle, up, middle, down, middle, and then we can continue. Okay, nice, smooth, sinusoidal curve like that. So again, we're using this to find the period of the function, and we're basically splitting that up into 4 parts because we know the graph sine or cosine is going to be, middle, up, down, middle, or whatever. Okay, looks good, looks good. Now here we have something that's a little strange. So what did we say? 2 pi over k equals the period, right? Right. So 2 pi over 2, dividing by a fraction, same as multiplying by the reciprocal. Don't worry, we got this. 2 pi over 1 times 2 over pi. So this is kind of cool. By this point you might be hating pi. So our period, so one complete pattern of the function is 4 radians. And I know that 4 radians, that's weird to think about, but here's a quick little review about what we mean by radian measure. Here's our unit circle, and we talked about the pizza crust. So look at this, that's a nice big piece of pizza. I'm hungry. So the arc over the radius would be 4. I'll write that. Arc over radius would be 4. That's kind of cool how that looks, huh? So if we were trying to draw that, let's see. It's going to be 4, so the pizza crust is going to be 4 times the radius. I don't know. This is my guess. A little more. Okay. That's a Pac-Man. Okay. So anyway, that's what this means. As far as our graph is concerned, oh great. As far as our graph is concerned, this is pretty easy. Watch this. 1, 2, 3, 4. Hey. And we know this is x, this is y. And these are radians. And this is, what are we talking about? The sine graph. So sine starts in the middle and goes up. So middle, up, middle, down, middle. Piece of cake. Middle, up, middle, down, middle. So I know that seeing radians in just numbers and not pies, that's weird. But if you wanted to figure out 1 radian, you can do this. Pi radians is the same as 180 degrees. So it's about 60 degrees. I think it's a little more. Just to help you picture what we're actually doing here. Okay, so if you got those for the answers without watching the video, you should congratulate yourself, pat yourself on the back, and there we go.